Today, physics, part 2. I'm Mr. Bruin. I am one of the lead science teachers for the district, for those of you that don't know that. So I'm not actually SEM staff. I work for the district. And so this year I'm teaching physics B, no, sorry, I'm teaching physics C, mechanics and E&M. We'll talk about that in a minute. First period, the second period, I'm in room 333 if you need to find me, teaching physics B to SEM students, the class that you all took last year. And then third period, I'm going to be in room 316. Third and fourth period, I'm going to be in room 316 teaching tag students. Let's see. Oh, let's go over the syllabus quick. For those of you that are paying attention, this is identical to the one in Physics B. Absolutely identical except for a couple lines. If you go onto the text, our text is a Tippler book. It's a really heavy college textbook. Actually, it's a slightly outdated college textbook. You know, college textbooks, they update almost every year so they can make more money. You know that, right?
Yeah.
Yeah. They change like 2 words, change a couple figures in it, and then they resell it so that they can make more money. All right. So this is a textbook from maybe 5, 6, 7 years ago, but all the content is just fine. I'll warn you in advance, the Tippler textbook is not for light reading, okay? I'm not saying it's a bad textbook. I'm just saying if you're reading it to understand it for the very first time, it's technical, all right? It's not a bad textbook. It's just not like a nice novel, okay? So just be aware of that when you try and read it. That's going to be pretty mathematical in content, okay? As far as the textbook goes, you can take it home. You can use it as reference at home. We will reference it very few times in class. And when I need you to bring it to class, I'll tell you in advance, all right? So you do not need to carry it around with you all the time, okay? Because it's a pretty heavy textbook. And the college textbooks are made to tear apart. They're not made like high school textbooks where they're made where they know that they're going to have to last for about 8 years or 10 years. These are made to last about a semester. And then they start to spontaneously disintegrate. Okay, so just be careful with them. The binding in particular will pull off pretty easy. So just be careful with them, okay? Because you don't want to have to spend 80 bucks for it. All right, the rules of the class are real simple. Thinking is required, okay? Time's required, just like anything. It's going to take time. You're all seniors, so no excuses. You know what's expected. Please respect others. We're going to joke around here a lot, as you can tell. But when people put forth an answer or to a question, or they're having trouble with something that it doesn't make sense at the moment, that's required for them to get it straight in their brain. And if you make fun of them, then they're not going to ask questions and they're going to give up, and that's not acceptable. Okay? We're in a collegial society here where we're here to make sure that everybody does well. Okay? So help each other out. We'll joke around, but let's not make fun of other people. Let's make sure that everybody does the best that they can possibly do. And turn in quality work. We don't turn in a lot of things because we do e-homework, right? And we have tests. But whatever we do turn in needs to be neat. It needs to have your name on it. It needs to be able to be readable. And for some of you, making your handwriting readable is a difficult job. You need to work on it. So if I can't read it, I'll hand it back to you. Okay? And you can have to redo it. You know you need something to write with. You need a calculator. A TI-83 is plenty. Actually, you don't even need a graphing calculator. It's not required, but it is helpful. Grading policy is the same as last year. I had the big question marks on there. I just copied that from last year. Since we don't really have projects and that sort of thing, what I do is the same thing I did last year, which is when we take a test, it counts for a test. It counts for a project as well. And it'll count for the 6 weeks exam. Since our syllabus doesn't fall on a 6-week, do some stuff and then take a 6 weeks exam, the tests that we take will count for the 6 weeks exam. So it ends up being pretty similar to the way it was before, which worked just great. So everybody seems to be doing pretty well. So when we take a test, it'll count for a test and a project and for the 6 weeks exam. All right? If you have any questions on that or want to talk about that, I'll be glad to do it. But anyway, you need access to a computer. If you do not have computer access, if you do not have computer with internet access at home or something, please let me know and we'll see what we can work out. We'll do electronic homework. We have computers in here where you're welcome to download the stuff if you'd like. If it's going to be an issue, you know, we always have technical issues with internet as the year goes by. Just let me know, and if you're going to have a problem, let me know in advance, please. Okay? And the test will be AP style, as you know, and we'll have about 2 to 6 weeks. So let's get out the calendar, which is this lovely document right here. Okay? Now, this is the calendar for the whole stinking year. Now, we will try our best to keep this calendar. It's a pretty strenuous calendar just because we'd like to finish early. So, because if we can finish early, then we have time to review. Sessions are marked on here. Our first Saturday prep session is December 12th. It's on the calendar. Normally, it'd be the Saturday right before finals, but it's a little earlier. Yes?
I got here really late. Our bus got here really
Okay.
late.
All right. That's fine. Just go ahead and have a seat. Actually, Carter's there, so just have a seat back there, I guess. All right, and then our second one is March 27th, and then we have our traditional one, the Saturday before the AP exam, which is May 8th. And our exam is May the 10th. Yes, sir. Okay, let's talk about this quick. Get out this pink sheet of paper. This just tells you what we're going to cover. Remember last year we covered thermo? No thermo this year. No. Everyone's happy. One test you passed? Oh no. Oh, you aced it. Actually, thermo is one of those weird topics. There's a couple of them that a few people love, but most people are kind of.
Do we have fluids?
Okay, no thermo, no fluids.
Oh my God.
Okay. No modern physics of any kind. And no waves or optics. Hey, waves and optics are pretty easy, actually. Well, the first level is easy. The next level up, it gets kind of scary. Okay, so here is all we're covering. We're only covering 2 major topics from last year. Newtonian mechanics, which is kinematics, Newton's laws, forces, work energy, power, momentum. We'll have circular motion and rotation and oscillation, which is like simple harmonic motion, and gravitation. That's it for mechanics. That covers the first half of the class. And that will be one of the tests that we'll take. The second test that we'll take, for the AP test anyway, is electricity and magnetism, which is actually even a tighter amount of material. It's a much smaller section of material than even Newtonian mechanics. But the E&M is the place where we get into some serious math, okay? All that calculus that you studied, we finally get to really use it, okay? We will use some calculus in mechanics, okay? There will be some calculus, but only 1 or 2 spots where it's, pretty strenuous. In E&M, there's quite a bit of like integration. We got 2-dimensional and 3-dimensional objects that we have to integrate for electric fields and electric potential and stuff like that. So don't be scared of it. It's not that bad. There's certain patterns that you can follow and to look for, and you'll be okay. All right? Actually, our students last year did really well in that. We got a lot of 5s and 4s. All right. Electrostatics. We have capacitors, conductors. We have circuits, magnetism, and electromagnetism. That's it, okay? Which is a pretty small amount of stuff, really. All right. The magical orange sheet, that's the constant sheet for this year. It should look very similar to the constant sheet from last year. I believe it's exactly the same. I haven't looked.
No, that's on
Yeah.
And this is table 2.
Yes. All right. The magical lime-colored piece of paper. Okay. Let's start with the easy side. If you look on the back, now this is kind of ridiculous that students don't know that this exists. Actually, you know what? Go back to the magical orange sheet of paper. This is really a huge amount of use for you, this orange sheet of paper. Particularly, if I can speak, particularly on the multiple choice, okay? If you look down there, it has the trig functions on there. And the trig functions are really special for you on the multiple choice, because the multiple choice, there's no calculator, right? And so every angle on the multiple choice is one of these: 0, 30, 37, 45, 53, 60, or 90. Now the 37 and 53 looks really weird, but that's a 3, 4, 5 triangle, right? So you only have 3, 4, 5 triangles, 30, 60, 90 triangles, or 45, 45, 90 triangles, okay? And so everything you need is right there. So don't get psyched out. It's all right there, okay? Actually on the orange sheet as well. Oh, I think we're through with that orange sheet, okay? Just make sure you know what's on there because it's helpful. Second thing is the green sheet. Turn it to the back, okay? When you're in the middle of a test and your brain freezes up and you can't remember anything, it does have geometry and trig formulas on the back, and we will use these formulas for three-dimensional objects, two-dimensional objects. They will be helpful for us in this class. Also, it gives you some basics of calculus, okay, in case your brain just goes dead, okay, to remind you of all that calculus that you've already taken, okay? All right, because you'd be surprised the things you forget on a test. You'll forget strange things on the exam. Just remember, most of what you need to remember is going to be on these two sheets, okay? So when that happens, just remember, you have a little help sitting there. Okay. Okay, let's go on to... Let's go on to this. Okay, there's going to be a few things that I'm going to give you for an assignment in just a minute, but before we do that, we're going to start reviewing already from last year, okay? We're going to start doing little kinematics. Yes? Oh, not both of them. What?
Turquoise.
Oh, turquoise.
Really? Oh, that guy.
There you go. Oh, that's what I need to talk to you about. Thank you for reminding me that, because I didn't have those here. The turquoise sheet. So we've gone through syllabus, equation sheet, constant sheet. We need to talk about e-homework.
We can skip that.
No, we got e-homework assignment. If you look on your calendar, we have an e-homework assignment due on Wednesday. All right. Now, on the turquoise sheet, or this dark teal, okay, electronic homework. All right, you need to, between now and Wednesday, get online with UT, and if you don't already have a UT electronic ID, how many of you have an electronic ID already? Raise your hand. Okay, who does not have an electronic ID already? Excellent.
She didn't.
Ramirez. Wendy Rodriguez. Elena Ross.
Still good. It should still be good. They should still have you. Okay. If you don't remember, yeah, we cannot do it.
And Spaniel Gospel. He goes to the office at this time.
All right. Many of you have probably forgotten your password or maybe even your EID. All right. to get to the EID, if you just type in Google, if you type UT it'll direct you to the website. Actually, if you just type UT and then Quest, it'll direct you to the Quest website, but before you get there, it'll take you to the EID login, all right? And on the EID login, it will, there will be a spot where it says, you know, forgot your ID or whatever, and you can request to, you know, have it sent to you or whatever. It's really best if you do not put a duplicate EID in, all right? Because if you do, what will happen sometimes is they'll cancel duplicates or something weird like that, and you won't be able to log in, all right? Because they only want one EID for each individual, okay? Now, some of you who will be applying to the UT system, they will give you a new EID perhaps, and if they do, it may jack up your EID for logging in for Quest. Okay, if that occurs, that's occurred to a couple of students now. If that occurs, then we'll work with it when it happens, okay? I don't have any control over that system, so you're going to have to go through them to get your electronic ID, all right? So if you just type UT and Quest, or UT and EID. Actually do Quest, because then once you log in, it'll take you to Quest, all right? On Google, it'll take you to the site, all right? If you have trouble finding it, someone will remind you. Actually, it's right here on the bottom. It's quest.cns.utexas.edu, and then you'll log in as a student, okay? Yes, ma'am.
Are you still gonna take homework on paper if, like on the day it's due?
Yes, if your computer crashes or your internet system burps and doesn't work, then on the day that it's due, if you're working out your electronic homework and you can't get it done, then just turn it in on paper, okay? The next class period, all right? Just try not to make a habit of it. If it becomes a habit, then we'll have to talk about it, right? But generally, those of you that had me before know that's just the standard policy. Thanks for reminding me, okay? That way, if it starts not to work, you can't submit your stuff, just keep working it out and then turn it in on paper the next time, and then I'll just grade it by hand, okay? Everything is due at 12 midnight. Actually, it's due at 11:59 p.m. to get away from the possible, if you put, it's actually 12 a.m., but that sometimes is screwed up in some computer systems. So to avoid it, make sure it's not the next day or at noon or in the morning or something, then it's 12:59 p.m., all right? What else was I going to say? Oh, you need our class. Write this down. 11264 is AP Physics C. All right, 11264 is us. I may not have any of the homework published just yet. I got all of Physics B up and running. I don't remember if I got Physics C, the first set of homework, published yet. Okay. So it's all on mine, but it may not be available for you to see yet. So I need to write that down. So we got that done. Any questions? Don't forget, 11264 this year. That's Physics C. All right, now. Okay, let's talk kinematics from last year.
Can you make the font bigger?
Can I make the font bigger?
Yeah. Sorry, I'm blind.
Do you still not have glasses?
One out of
No,
four
I
people
have
in here have
contacts.
glasses.
They're just, the font's still
Don't have
small.
glasses.
It was at 10, Mr. Bruin.
I read it. I could.
You're close.
And I had 10.
All right, there we go. Okay, do you remember your kinematics equations? What are they?
X naught plus C plus 1/2 AC squared.
There we go. Nice. All hail. That's equals x naught plus 1/2 plus 1/2 AT squared.
B naught plus
Plus 18.
okay.
Squared.
And then B squared equals B naught squared.
Yeah, this right here is the same as D in pre-AP. Okay, this Now, x naught most of the time is 0, right? But it doesn't have to be. This just says at whatever time this is, that's where we were located. And the 0 just means at the beginning of time. All right?
The beginning of time.
And so this time is any time afterwards. Technically, this is delta t, how much time has passed. There technically should be a t minus t naught there if we really want to be
It's already turned
technical
in.
about it. Is that
It's already turned in.
No. All right. So there we go. So those are our three equations. All right. And we know what x and x naught is, and v naught is, and a and t, right? Okay. What does x tell you?
Displacement.
It's x is displacement, units of meters. What does it tell you?
How far the object is from the origin?
Yeah, it tells you a location referenced to some place we call 0, right? There has to be a 0 spot in order to measure where something's at, right? Okay, so x and x naught are the two locations at the beginning of the time and at some time later, okay? All right, what's v? Velocity. So v naught is the beginning velocity and v is the ending velocity, right? And what does velocity tell you? It tells you speed and direction, right? How fast you're going and which way. Okay, now if we're talking x, then it tells you negative 20 meters per second. What does that mean?
It's going maybe a second back. It depends on what you set your direction as.
Yeah, we gotta know which way is positive. So if this is x and this is 0, positive and negative x, usually positives to the right, it doesn't have to be, but positives to the right, then that would mean 20 meters per second that way, right? Okay. All right, and a?
Acceleration.
Acceleration. Now, what the heck does acceleration tell you?
Change in velocity.
Change in velocity with time. That's all it tells you, okay? So here you go. If this is my velocity, v naught equals that, and my acceleration equals 3 meters per second, positive, what's this object doing? If this is a car,
Slowing down.
I don't think slowing down.
No, it's slowing down.
the answer is it is accelerating, but here's the difference. In the English language, acceleration generally means to speed up, right?
So it really means changing speed.
But acceleration in physics technically means a change in velocity. Okay? So the question then is this way, right? So if you're moving this way, but you're accelerating this way, if I'm moving this way but accelerating that way, what am I doing?
Slowing down.
I'm slowing down. In order to accelerate, speed up, like we use in the English language, then if I'm moving this way, which way do I have to accelerate to speed up? Accelerate that way to speed up, right? Because what this tells you is how, oops, I wrote it wrong. Nobody's told me already. Meters per second squared. Technically, it's meters per second every second. This means that you're changing 3 meters per second every second in that direction. So after 1 second, how fast would this thing be going?
17.
So it's going this way, but it's accelerating that way, so 17 meters per second after 1 second. After 2 seconds, it would be negative 14 meters per second. Because you're changing towards that direction 3 meters per second every second. Yeah.
Technically, sooner or later, start speeding up.
Ah, that's true. So I should have picked something easier. Let me pick an easier number. Let's change that to 5. So after 1 second, you would be going negative 15 meters per second. After 2 seconds, you'd be going negative 10 meters per second. After 3 is negative 5 meters per second. And after 4 seconds, you would have a velocity that equals 0. But if the acceleration continues, then what would happen? You would start to speed up this way.
A trick question.
Yeah. And that seems really weird when you draw it on the board, but that happens all the time. Here you go. Here's the example. Because you're going that way, but you're accelerating this way. So eventually you stop and then you turn around and come back, right? Right? Yes.
Let's just say yes.
Yes. Bobblehead. 2 seconds. Determine the sprinter's constant acceleration during the first 2 seconds. Will you do that for me, please?
Make the font bigger.
What's that? Bigger?
It is kind of hard.
My goodness. Almost missed my chair.
No, that makes it harder. 27.
Nice.
There you go.
Rockwell.
No.
I'm not gonna call it.
There you go.
That's
There you
too
go.
big.
That's too big. There you go. Is that better? Can you read that? Determine the sprinter's constant acceleration during the first 2 seconds. All right, you're working this as a table. All right, which equation do we want to use? First one? All right, where do we begin? 0? 0 initial velocity, so 0, we start at 0 location, we start at 0 velocity, we have this, we know that we travel how many meters? 10 meters, 1/2 a, and it takes us 2 seconds squared, so we end up with acceleration of, what is it, 5 meters per second squared?
Yes.
Okay, there we go, piece of cake. All right.
Oh, that was a question.
Wow.
My shoulders are
It's gonna
hurting.
be a long year.
The way
Okay,
you-
determine the sprinter's velocity after 2 seconds have elapsed.
Okay.
Oh, sorry. So what are we looking for? We're looking for V when? After 2 seconds. So we're looking for V sub 2 at 2 seconds, right? Okay, how can we do that?
The second equation.
Second equation, V2 equals V naught plus AT, when the time is going to equal 2 seconds, because that matches up with this, right? All right, so what's our initial velocity? 0. So V2 equals 10 meters per second. Bingo. Excellent. All right, determine the total time needed to run the full of 100 meters. Okay. All right, let me let you think about it for a minute.
You say it runs 11 seconds?
Can we see the?
Well, we need to know the initial information.
Oh.
Here.
I did it as
There you go. There's all the information. Okay, so we're getting to the point where we might need to write down all the information we know. We know that at time equals 0, the velocity is 0, the location is 0. We know at time equals 2 seconds that the velocity at 2 seconds is 10 meters per second. We also know that at, we do not know where we're located at 2 seconds, do we? Yes. But we do know that the acceleration from here to here is 5 meters per second, right?
We're at 90. I mean, we're at 10.
We're at 10.
We're at 10 meters.
Sure?
10
Yeah.
How do you know?
It told us.
The
The remaining 90.
Ah, so we do know 10 meters. So it was given after all, right? Okay, so what we need to know then is somewhere out here, we end up at 100 meters, right? We do not know how long that takes. And we do not know, or do we know the velocity there?
Yes.
What is it?
10.
Why?
Is it constant?
Ah, because it's a constant velocity from there on out. Okay, if this is a constant velocity from here to here, what's the acceleration from here to here?
Zero.
Ah, if the acceleration is 0, look what happens. Notice that this equation becomes this equation, which just tells you the velocity stays the same. And this equation becomes this equation where it says the velocity stays the same. And this equation becomes, that goes away, and we're left with, it tells you, you travel this many meters starting from here at this velocity in time, right? Okay, so that's the only equation of any use to us in here. Does that make sense? So all we have is x equals x naught plus v naught t. That's all we have. And does that tell us anything useful? Where do we begin?
2 seconds.
At 10. So you know what? We're not really starting at 0. We're starting at 2, aren't we? We start at 10, we end up at 100. Our velocity is 10 meters per second, and that tells us the time it takes us to get there, which is
9 seconds.
9 seconds. 100 minus 10 is 90, divided by 10 gives us 1 second. 9 seconds.
And add the other 2 seconds.
Ah, so our answer is not 9 seconds. That will give you no points.
Plus 2.
Plus the 2 seconds we started with, so 11 seconds total. There you go. All right, now the last thing. On the axis below, sketch it. What would it look like? All right. Anytime you have to sketch a graph, now notice that they already have the axis labeled for us, so that's nice. It makes it easier. But if we do have to label the axis, don't forget, we need to label it, number it nicely, blah, 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 right? So somebody can read it. When we have to do one of these things, the most important thing to do is to put down points we already know. What are points we know?
At 2 seconds. 2 seconds, we're at 10 meters.
At 2 seconds, we're here. What else do we know?
11 seconds.
At 11 seconds, we're at 100.
And it's the straight line between those, the curvy.
Is there another point we know? There's one more. Thank you.
No,
At time equals 0, we're at the starting line.
straight line between those, but you don't want it to be like a jerky line.
Ah, okay. So here's the. Once you have your points, your important points, the next thing is how do they connect? Do they connect like this?
No.
All right. So,
First one's concave.
all right. You're accelerating, right? So this is concave up, right? So a lot of you will do this.
But you don't, no.
Smooth circling.
Transition. That's what I meant. I don't mean a curvy.
All right. So wait a minute. On an x versus t graph, accelerating looks like curve, right? Curve up, curve down. This is a positive acceleration. This is a negative acceleration. Now we'll review this, okay? Because I know a lot of you are like, oh, whoosh, just went right past it, right? Hang in there, okay? X versus t. We're going to go over this tomorrow on Wednesday, okay? But if you're not accelerating, if acceleration equals 0, it could be like this, or it could be like this, or like this. It's a straight line, okay? So we connect these two with an acceleration of 0 with a straight line. Wow, that's pretty straight. And this is going to be a curved line, and since it's a positive acceleration, it's concave up. And the key thing is to make a smooth transition. So this is quadratic, this is linear, okay? So this is a positive acceleration. All right, this is a Physics B exam question. All right. So there you go. There's your review for Physics B. There you go. The entire course, we just reviewed it. Now I expect you to know everything. Okay. All right. So let me give you your homework assignments for today.
Wait, there's something apart from
This is just to remind you how to convert units. How much money do I have in euros, yen, pounds, Hong Kong dollars, Sudanese dinars, and Venezuelan bolivars. Okay, now, Show your work, please. Show your work, please. And please round it to the proper number of sig figs. Now, the base currency shows 2 sig figs. The exchange currency shows 3. What should you round it to? 2. Okay? Should round it to 2. Okay, on the back side of this is new. This is our Physics C math skills, just to remind you of the things that you should remember. Near the bottom, there are, I believe, one of those questions on the bottom, 12, 13, 14, or 15, there are, I'm sorry, I think it's 15. I think there are multiple ways to answer that, okay? I think there's at least 3 answers for one of those. I don't remember which one. Okay? 10 and 11, I just need a sketch. Just a sketch, what does it look like? All right? Okay. So we got that, math skills, and then because we're in Physics C, pink sheet is derivatives. To remind you of how to do your derivative. Okay? Now, I will tell you that probably most of you will be better at calculus than me, because I took my calculus many, many moons ago, and lots of it. And so you have used it more frequently, closer in your lifetime to this point in time than I have. So, I will be relying on you to remember your calculus, because, you know, I have to dust the rust off of my calculus every year. Okay? This is the only class I use it in anymore. I used to use it as an engineer some, but...
You were an engineer?
Yeah.
Would you engineer?
I was an aerospace engineer. I worked for Bell Helicopter.
And you didn't really use calculus?
Oh, that's cool.
And we used calculus, yes. We used calculus. We used a lot of finite element theory and a lot of Fourier transforms and things like that that you haven't learned yet.
Yeah, I'm gonna be an English major.
Oh no, I have to.
You can be that major. Not bad, really.
I know.
That's not
I'm
really
sorry,
good.
but that's kind of just real why.
Oh, I love
Did you do NASA this summer?
Yeah, that was awesome.
No, that's why.
Hey, who all did NASA this summer? How was it? Was it good?
Cool.
Yeah.
No.
I don't know.
No.
You didn't
I
like
like
it?
you, I like you,
loved it.
Tyler.
You didn't like it?
If I launched something, people would die.
Yeah,
It was beautiful to watch.
For our senior project, my senior year in college, we had to design a plane. And I'm thinking, nobody needs to get on
I
this
still
plane.
feel my legs.
That's nice one else to have to be nice.
So, all right. Now, everybody, I'm going to give you the rest of the class period to work on your homework. When we show up on Wednesday, I will collect the yellow sheet front and back and the pink sheet. I will count them as 3 separate grades. Okay? So yellow sheet front and back, which shouldn't be too strenuous. There are actually a couple of them on the back of the yellow sheet, the math skills, that students have generally had questions over, like number 8. How do you solve for t? Quadratically is the answer. Okay? It's really not bad. If you remember your quadratic formula, you can answer that. Okay? There are a couple others on there that take you a little bit of effort, perhaps. But the yellow sheet is not intended to be difficult, just to remind you. The pink sheet is derivatives. Most of those are pretty straightforward. There are a couple of zingers, but most of them are pretty straightforward. Okay. There's graphs. Oh, no, I'm sorry. Everybody? Okay, here's the deal. On this one, you probably have enough room to answer most of these right here. Okay? But if you run out of room for some of these on the bottom, you can do it on the back if you like. You do not have to waste another sheet of paper. Just make sure that you number it, and it's easy for me to see what the heck it is. Because the rule goes, if I can't tell what the heck it is, I'll hand it back to you and you have to redo it.